Okay, and then so for this one they asked us to calculate the pH of a solution after we mix two things. We're mixing hypochlorous acid with sodium hydroxide, so really HOCl and OH minus. So we're going to have kind of a neutralization reaction here. And so we can think of that, we have HOCl plus OH minus going to give us OCl minus and water. And again, the water is not going to impact our equilibrium information here. So we have ice with this, and we can use this to think about, what are the concentrations of these two in the beginning, so we can see which, if one's a limiting reactant, which one we have left over, and we can try to figure out what we're going to have after this reaction is done. Okay, and so for that hypochlorous acid, we're going to have 40 milliliters of 0.14 molar, and then we're diluting it with using the other 10 milliliters. We're going to dilute it to a final volume of 50 milliliters. And so by diluting in that way, we're going to end up with a concentration of 0.112 before it starts. Okay, and then so for OH minus, 10 milliliters of that 0.56 molar diluted to a final volume of 50 milliliters. So I know they don't say volumes are additive here, but they probably would if this is a recent question. This one comes out to 0.112 as well. We don't have any of this, and we don't care about water. And so our change here, so we really don't have a limiting reactant in this case. Both of these are going to be the same. So we're going to end up reacting the 0.112 to a point where we have none of this after this reaction is done. I know this is not really an equilibrium kind of thing, but it's just kind of helping us keep track of this information. OCl minus, on the other hand, when we neutralize each one of these, and it's going to be 1-to-1 here, we're going to produce the same amount here. So for our change, we're going to end up with 0.112 molar OCl minus. Okay, and so they ask us for pH then. They tell us OCl minus, which we know is a base. It's a conjugate base of hypochlorous acid, and we calculated its Kb. Well, our Kb then expression would end up being, if we go back to the previous page here, based on this would be the HOCl minus, or HOCl, excuse me, times OH minus over your OCl minus, and that's going to be equal to our Kb of the 3.1 times 10 to the negative 7. And so with that information then, we would do ice for this too, but we can do it pretty quick. This is going to be the HOCl and the OH minus concentration are going to be X. So this is going to be X squared over the concentration of OCl minus, which we just discovered calculated to be 1.112 molar. Okay, and so if you do that, we solve for X, which is also equal to OH minus. Our OH minus concentration comes out to 1.8 times 10 to the negative fourth, and if we take the negative log of that, we can get our POH. POH then is 3.73. And by association then, they're asking for our pH. Our pH, which would be 14 minus this number, would be 10.27.